Okay, we're looking at LSAT 63. This is the June of 2011 LSAT Analytical Game 3. Accompanies 6 vehicles. H, L, P, R, S, and V are serviced during a certain week, Monday through Saturday, 1 vehicle per day. So we have H, L, P, R, S, and V. We assume that this is a sequential game. Highly unlikely that there will be any grouping aspects such as, what color are the cars or something like that. We're looking out for that, but we don't know until we look at the rules. But as of right now, we're almost 99% sure we're just dealing with a sequential game. We're only dealing with 6 variables too, so it sounds promising. The following conditions must apply. At least one of the vehicles is serviced later in the week than the hatchback. So we know that H cannot occur 6th. Okay, the Roadster is serviced later in the week than the van and earlier in the week than the hatchback. So we have V is before R is before H. Either the pickup and the van are serviced on consecutive days, the pickup and the van, or the pickup and the sedan are serviced on consecutive days, but not both. So I put the parentheses here to say there's no inherent order. Okay, it can be PV or VP. There's an exclusive or indicated by this line underneath, okay? And then the same thing with the parentheses here. We can have anything like P and S or S and P, right? It's an option. But we know that we can't have this. This is what this means. You could never have a situation where P is in the middle and S and V are on the other sides. That would not work, okay? So we know that we can't have that. And then the last rule, the sedan is serviced earlier in the week than the pickup or earlier in the week than the limousine, but not both. So that we know that this means either L is before S is before P, or P is before S is before L. Okay, so we want to utilize the hierarchy of rules to solve the scenarios. And the scenarios are very quickly solved in this game, but it's extremely difficult to kind of get an idea of where to start with this, all right? We have an exclusion rule. That's actually very, very helpful, but we really don't care about indicating that H can't go 6. That's irrelevant, really. Irrelevant as far as diagramming it, because we know we're going to be able to know where H can go. Okay, these 2 rules are not helpful at all in the very beginning that we look at trying to solve scenarios. They're very, very helpful, just like a conditional statement is, if we've got something filled in. So the question becomes, what do we do? All right. So we know that we've got 6 variables. Okay, we know that we have this 3rd order rule saying V is before R is before H. Okay, and we know that H can't go 6, so we have a 3-5 distribution going on. And so automatically you should understand that this is a very quick distribution. There are 10 things that can happen when you've got 3 variables in a sequential order and 5 spots, and you should just know that this is how to approach this game. Now you only know this by experience, right? By practicing. Okay, with regard to V and R being close, when H is distributed like that, that's all that can happen, all right? So let's just move R over now. Okay, that's all that can happen when we move R over, and then let's just complete it when V is all the way to the left. This is the last thing that can happen. All right, great. There's 6 things that can happen. Let's take a look at what can happen when we move V over 1. We put V here. Okay. Okay, that's all that can happen with regard to V and R being close in that situation. And so we just move we move R over. Okay, and then now just to finish it out. Okay, 10 things. And 10 might seem like a lot. Many people say that's way too much, but we're just distributing V, R, and H. You should be able to do this in, like literally 30 seconds, create this. And you know, we've got half of it filled in, so we should be encouraged at this point in time. Now, who is left over in this whole mess? It's L, S, and P. So let's focus on L, S, and P. What do we know about L, S, and P? Who goes in the middle? It's S. All right, so we can automatically just put S in the middle of these three spots. Okay? Okay, so now the question becomes, we're only dealing with P and L, okay? So let's look at the first one. What can happen with regard to P and L? Well, they can go in either order because of this rule right here. All right, now what happens here, we don't have P next to V in any of these sides, right? P is not, or it has no possibility to be next to, let me restate that. P and V cannot be next to each other in these two. So we know for a fact, no matter what, that P and S must be next to each other because we've got to have this PS thing going on. So now it's a matter of filling in L. All right, and if you think about this, because we put S in the middle, L and P, our LPS thing will always work, whatever way we fill in L or P, because we placed S in the middle of everything. Okay, so now we just look back at this. Because V and S, you can have a P and a V or a P and an S, so we can just do an option. Okay, and we know that S can't be next to P here, so we have the V and the P, and then the L here. Now, what happens if we have to put a P next to V and S here both, but it violates this rule, so this falls out. Okay? Now let's look at this. Again, we have V and S that can be next to each other. P can be next to both V and S, so we know that it's an option. All right, here we can't have P and S, so we know we have to have P and V. Here is the same thing with P and V. We can't have P and V here, so we know that we have to have P sitting next to S. And we are done. All right, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 scenarios, and it's done. Now look, you have to practice this to understand how this works. This is not some sort of thing that you just kind of create out of thin air and you're like, I can do it. You can't. I mean, it's a 3-5 distribution. You should know that there are 5 spots, and there are, with 3 sequential variables, there are 10 scenarios that can be created. Bam, you knock them out. Then you just look and say, oh, you know what? I have 3 variables left. I know that S is going to have to go in the middle of those. Boom, all of a sudden you have 4 out of 6, and then it's all over but the cry and just filling in L and P. Again, I think that this is a very critical game. If you are a scenario solver and you can't do this, you need to do this enough times to where you actually can do it. This should be something that's second nature. This should always be a possibility that you're looking for. This is old school LSAT logic games, something that doesn't pop up very often, but it's something that you must know how to do if you want to succeed at this test. Okay. 11, which one of the following could be the order in which the vehicles are serviced from Monday through Saturday? Okay, elimination question. We go through each rule, figure out which answer choice violates said rule. Last answer choice standing, that's the one. So let's take a look at the first rule. We know that H cannot occur last. That is C. C drops out. Okay, the second rule is we need this sequence, V, R, and H. If you look at A, we have a situation where we have H, V, and R. So A falls out. The third rule, we need to have either a P or a V or a P or an S. If you look at D, we have a P and an R or a P and an H. D falls out. And then the last rule, we need LSP or PSL. If you look at E, SPL is what occurs. That cannot be, thus we are left with answer choice B. That is the correct answer. Okay, let's look at 12. Which one of the following cannot be the vehicle serviced for Thursday? All right. So we are looking at Thursday. Excuse me. Thursday is here. We could have S, H, P, and L. And Thursday here we can have R also. So we have S, H, P, L, and R that all can go on Thursday. H, L, P, and S can all go. That's A through D. What cannot go is the van. That's E. Thus, it is the correct answer to the question. All right, 13. If neither the pickup nor the limousine is serviced on Monday, then which one of the following must be true? Okay, well, we're just looking at these first 5 scenarios because P or L is happening on 6 through 9. So what happens on the first 5? Which one of the following must be true? H and L are serviced on consecutive days. Well, it happens here, but it does not happen in scenario 4. Again, because we're being asked what is a must be true, all we have to do is find one scenario that breaks that condition, which is H and L occurring consecutively, and it is a no-go. All right, so A, we have disproven because H and L don't need to be next to each other on scenario 4. Let's look at B. The hatchback and the sedan are serviced on consecutive days. It happens here, happens here, happens here, happens here. Not on the first scenario, thus it is not a must be true. It cannot be the answer to the question. Let's look at C. The van is serviced on Monday. We'll take a look. Yes, absolutely. Has to happen. It is the correct answer to the question. Let's look at D, though. The limousine is serviced on Saturday. Does not have to happen in scenario 4 or scenario 1. And E, the pickup is serviced on Saturday. Well, not in scenario 5. The pickup only has to be serviced in scenario 2 on Saturday, but none of the other ones. As such, E is not a must be true. It's a could be true, but it's not a must be true. Thus, we know for a fact that C is the correct answer to the question. Okay, 14. If the limousine is not serviced on Saturday, then each of the following could be true except. Okay, well, let's take a look at what we've got. The limousine is not serviced on Saturday here and here, and I'm going to go ahead and circle what has to happen in those situations. And the limousine is not serviced Saturday, possibly here either. Okay, so we are looking at 1, 2, 4, and 6. All right, so what does it ask us? Then each of the following could be true except the limousine is serviced on Monday. Well, actually I have to apologize for this. This is incorrect. The limousine could be serviced on Monday in scenario 6. Therefore, it is a could be true. Let's look at B. The Roadster is serviced on Tuesday. Well, that could happen here in the first scenario, so that could be true. C. The hatchback is serviced on Wednesday. Well, that could happen here in the first scenario as well. Let's look at D. The Roadster is serviced on Wednesday. It could happen in scenario 6, so that could be true as well. And then E, the sedan is serviced on Wednesday. It cannot happen here, it cannot happen here, it cannot happen here, and it can't happen here. Thus, E, because it cannot be true, and because the question asks us what could be true except, E is the correct answer to the question. The sedan cannot be serviced on Wednesday if the limousine is not serviced on Saturday. Let's look at 15. If the sedan is serviced earlier in the week, if the sedan is serviced earlier in the week than the pickup, then which one of the following could be true? Okay, well, the sedan could be serviced earlier in the week than the pickup here. All right, the sedan is earlier in the week than the pickup here. It's not here. It can happen here as well, not here. It can happen here, not here, not here, and not here. So we are now looking again, I believe, at the same scenarios, 1, 2, 4, and 6, and let's see what we come up with. So which one of the following could be true? The limousine is serviced on Wednesday. It could absolutely happen in scenario 2. That's the correct answer to the question. Let's keep going, though. The sedan is serviced on Wednesday. It cannot happen here, it cannot happen here, it cannot happen here, and it cannot happen here, so that cannot be true. C, the van is serviced on Wednesday. It doesn't happen in the first 3 here, and the van is serviced on Tuesday here. As such, C cannot be true. D, the hatchback is serviced on Friday. It does not happen here or here, doesn't happen there, and doesn't happen there. Thus, that cannot be true. And then E, the limousine is serviced on Saturday. It never happens. We have P, 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 and P on Saturday. Thus, we know for a fact that A is the correct answer to the question. Let's look at 16. If the limousine is serviced on Saturday, then which one of the following must be true? Okay, well, let's take a look here. We got to kind of change things up here. And I'm circling these just so you guys can see what's going on. When you're good at this, you can look at, I typically will leave one option on a wholly solved scenario so I can look and see, but I just want to make it clear to make sure that we don't have any confusion. And then okay, so what scenarios are we looking at? If the limousine serviced on Saturday, we have this one, this one, this one, this one, this one, this one, and this one, and also this one. We're only actually not looking at one scenario, so we're looking at everything but scenario 2. So if the limousine is serviced on Saturday, which one of the following must be true? The pickup is serviced earlier in the week than the roadster. Here we have PR, PR, RP here in scenario 3. We stop right there. It is not a must be true. So let's go to B. The pickup is serviced earlier in the week than the sedan. It happens here. Doesn't happen here, but this is not a scenario we're looking at. So we have pickup sedan, pickup sedan, pickup sedan, PS, 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 and PS. That is absolutely a must be true. As such, B is the correct answer to the question. Let's look at C. The sedan is serviced earlier in the week than the roadster. So do we have S before R everywhere? No, we don't. Not in scenario 1. Therefore, C is not a must be true. Let's look at D. The hatchback and the limousine are serviced on consecutive days. Doesn't even happen in scenario 1. That is not a must be true. We move to the next one. E. The roadster and the hatchback are serviced on consecutive days. It happens here, doesn't happen here, but this is not a scenario I'm looking at. The scenario I am looking at, scenario 3, they do not have to be on consecutive days. As such, E falls out, and we are left with B. We've proven that B is the correct answer to the question. 17, which one of the following could be the list of vehicles serviced Tuesday, Wednesday, and Friday, listed in that order? So do we ever have on Tuesday, Wednesday, the PH situation? No, we don't, so A falls out. Let's look at B. Do we ever have a PR situation on Tuesday and Wednesday? It could happen here, and we're saying PR and then H on Friday, so that doesn't work. Let's look at scenario 5. PR and H on Friday, that is absolutely correct. B could be true. We could have a pickup, a roadster, and a hatchback Tuesday, Wednesday, and Friday, respectively. Thus, B is the correct answer to the question. Let's look at C, though. S, L. Do we ever have an S and an L here? No, we don't. And we don't have an S and an L there? No, we don't. So that falls out. Let's look at D. Do we ever have a V and an L? Well, we don't have it here, and we don't have it here either, so that falls out. And then E. Do we ever have a V and an R? Yes, we do. And then the question is, do we have a limousine on Friday? No, we don't. It's either S or H. So again, we've proven that B is the correct answer to the question. I want you guys to understand that the way that I did the last one, I wasn't trying to look at all 3 of them at one time. I was just looking at 2, and then if the 2 worked, then I would look at the 3rd. Okay, that concludes Analytical Game 3, LSAT 63, June of 2011. Thank you.